So let's see what we can do with these laws of proposition. Now, there's a bunch of them, and I'm not going to expect you to memorize all of them. Now, some of them, maybe, right? De Morgan's laws, we use these so many. This is a good one to actually put to memory. But being able to use them, so seeing this table and say, okay, how do I use these, will be helpful. So here we have a compound proposition. How can we apply things? So right away, what we see is that we have the negation of an and operation. So this brings to mind De Morgan's law. So let's go ahead and apply De Morgan's law. So what does that do? It takes the, I'm going to copy this down because we're going to adapt it. So it takes this not operator, right? And it distributes it distributes it inside the parentheses, and then it changes the operation from an and to an or. So now I'm going to insert the or operator by inserting a special character, and there's the or. Okay, so that's De Morgan's law. So when I do that, I'm going to identify this was De Morgan's law. So I'm going to write it down there. It's like, okay, that's what I used to get to this space, was De Morgan's law. And we can go ahead now, we just have a single or, so we can go ahead and get rid of the parentheses. And now do you see anything else we can apply? So look at this double negation, right? And we know that when we do that, what we end up with is back to Q again, right? And we can find that in our table. If we go down and we can find it, there's our double negation law. So let's copy that and see how we apply that. Right? And what that means when you have not Q, you end up with just Q. So now we have Q or not P. So what do we want to apply next to make this more simple? So let's go ahead and see if we can find anything down here that might be helpful with that. We have Q or not P. And if we look down here at conditional identities, and this really is a project of looking and finding one that might apply. And so down here we have not P or Q, which is not exactly what we have, but it's pretty close, right? It's just, we just have to swap the order, which brings to mind, oh yeah, we can swap the order because we have the commutative laws, right? And so if we have an or operation, we can swap the order, no problem. So let's go ahead and do that. So let's just swap the order. Now this one is not going to play out nicely. So I'm going to do not P. I mean, this isn't easy to type, right? Not P, and then I need an or. And Q. Q I can type easy. And what we did here is we just used the commutative laws. And we just said we can just change the order of it. And now that we have that, then we really do have this not P or Q, which is P implies Q, or if P, then Q. So what we ended up with is this. And this is a simple, this is a single operation, right? So here, let's go ahead and say we did this with the conditional identities. And what we've done is a couple of things. One, we've simplified. So we've gone from this complex or compound proposition to this more simple compound proposition. So we've done that. We've simplified. The other thing we've done is we have used these laws to show equivalence. So now we can say that this compound proposition is equivalent. And let's see if we can find that equivalent operator. Right, there it is. To this. And so we've showed equivalence. Now, before we showed equivalence with a truth table, and that's one way to show logical equivalence. But now we've done it by applying the propositional laws, or the laws of propositional logic. And so we've established equivalency. And we could double check this by creating the tables for these and showing that they're logically equivalent. So a second way to show logical equivalence.